In this video, I'm going to talk about the reducing properties of monosaccharide. Uh, in my last video, or let me just say the first video I make, I actually explained the classification of carbohydrates, and I said carbohydrate can be classified based on functional group as well. Then they can be classified as the first one, which is what? The aldehyde, and second one, which is what? Which is the ketone. Right? Which is the ketone group. Aldehyde and ketone. Now, based on this functional group, carbohydrates undergo reducing. They have reducing properties. That is, they have properties that has to do with reduction and oxidation reaction. And in laboratory, many tests are actually conducted to determine or to basically test for the reducing properties of compound having aldehyde or ketone. The reactions, the tests are, we have the case of Benedict test, Benedict test, right? We have the case of Fehling test, and we have the case of Bafford test, right? We have the case of Tolin's test as well, but these tests are actually conducted to test for the reducing properties of compound containing aldehyde or ketone, right? So the sugars generally are actually classified as reducing or non-reducing sugar. That is, they are classified as reducing sugar or non-reducing sugar. So one thing about reducing and also non-reducing sugar is that any sugar that actually have let me just say it has free aldehyde or ketone group, they are basically referred to as reducing sugar, right? Any sugar that has that, let me just say there is free aldehyde or free ketone functional group on that particular sugar, that sugar is referred to as reducing sugar, right? It's referred to as reducing sugar. And example is, let's just say we have the case of glucose, right? We have the case of glucose, right? Glucose is a reducing sugar, and the reason why is because it has free anomeric carbon atom. This is the free anomeric carbon atom, right? Carbon number 1. So that's free anomeric carbon atom. So in that case, that shows that glucose is a reducing sugar, and the reason why it's a reducing sugar is because it has free aldehyde functional group. It has free aldehyde functional group. That's just it. So that's the case of what? Of glucose. And another type of reducing sugar that we have is the case of what? Of fructose as well. Or let me simply say generally all monosaccharides are reducing sugar because they have free aldehyde or ketone group, and they can undergo these three tests in the laboratory. So these three tests are mostly important to determine the reducing properties of what? Of sugar, right? So one thing about the reducing properties of sugar is that the reducing properties of sugar is much more efficient in alkaline medium compared to acidic medium. It is very, very important. It's very, very efficient in alkaline medium compared to acidic medium. So that's actually the case of tautomerialization that I explained in my last video. I talk about the formation of endiol. So endiol is a very, very reactive reducing sugar, or simply just say reducing agent. It is very, very and highly reactive. So one thing about reducing sugar is that they have free anomeric carbon, that is free aldehyde or ketone group. And in that scenario, any sugar that has free anomeric carbon atom is referred to as what? Reducing sugar. And all monosaccharides are basically what? Reducing sugar. So what of the case of disaccharide? Those disaccharides are also reducing. They have reductive properties in nature, but there is this sugar that is very, very different, which is the case of what? Of sucrose. Sucrose does not have free anomeric carbon atom. So any sugar that doesn't have free anomeric carbon atom does not have what? Reducing property. So those sugars are said to what? Non-reducing sugar. For example, in the case of sucrose is the type of what? Of non-reducing sugar, right? Because they do not have what? It doesn't have what? Anomeric carbon atom. So any sugar that doesn't have anomeric carbon atom doesn't have free aldehyde, free aldehyde or keto functional group. So that sugar is what is non-reducing sugar. But any sugar that have free anomeric carbon atom, that is, it has free aldehyde or keto group, it is called what? Reducing sugar. So that's just it. So another thing that I need to talk about when it comes to reducing properties, and before I move to the reaction is that whenever you're talking about reducing properties of monosaccharide, right? Reducing properties of monosaccharide. Whenever you're talking about it, what I want you guys to understand is that the reducing sugar is not only attributed to the free aldehyde. It's not only attributed to the free aldehyde or keto sugar, right? So some sugar also have what? Alcohol functional group. Alcohol, don't forget that monosaccharide generally they contain, they are polyhydroxy in nature. So the alcohol group, that is the alcohol group, the hydroxy group of monosaccharide can also undergo what? Also undergo reduction. It can also undergo reduction. The aldehyde can also undergo what? Reduction. That's what we know, that one is general truth. And also the ketone as well also undergo what? Reduction. So it is not only the aldehyde functional group, this aldehyde functional group and what? Or keto functional group that undergo what? Undergo reduction. The alcohol functional group also undergo what? Also undergo what? Reduction, depending on the what? Oxidizing agent that is what? That is used. Right? Depending on the oxidizing agent that is used. So whenever we are talking about aldehyde undergo reduction. They undergo reduction to form aldehyde. They undergo reduction to form what? To form gluconic acid. Don't get it wrong. Aldehyde undergo reduction to form gluconic acid. That is, they undergo reduction reaction to form gluconic acid, while the terminal alcohol, or let me just simply say hydroxy group, terminal hydroxy group or alcohol group undergo reduction to form what? To form glucuronic acid. Glucuronic acid. So that's what I want you guys to understand. But there is always confusion about what of adonic, or what of ketonic acid or adonic acid. Whenever you're talking about aldehyde generally, whenever they undergo any monosaccharide that has aldehyde functional group, whenever they undergo reduction reaction, they will undergo reduction reaction to form adonic acid. Adonic acid is a type of aldehyde acid. That is, it is formed whenever aldehyde functional group undergo reduction reaction. But in the case of gluconic, this basically tells you that this is what? Glucose. Right? In the case of glucuronic, this basically tells you that the terminal hydroxy group is from what? Is from glucose. Do you get it? So aldehyde undergo reduction reaction to form what? To form gluconic acid, while the alcohol undergo what? Reduction reaction to form what? To form glucuronic what? Acid. And most of us really know that whenever you are talking about ketone, right? Whenever we are talking about ketone does not really active when it comes to reduction reaction, when it comes to reduction to oxidation reaction, right? Ketone do not really active, right? Except whenever ketone undergo what? Reduction reaction to form what? To form alcohol, right? To form alcohol. Ketone can never undergo reduction reaction to form acid. That's what I want you guys to understand. It can never undergo reduction reaction to form what? To form acid. There is nothing like acid of what? Of ketone, right? And there is nothing like ketonic as well. Yes, there's not like ketonic actually, but there is adonic, because aldehyde can undergo what? Reduction reaction. Then the terminal hydroxy group of aldehyde can undergo reduction reaction. Most of us really know from our basic chemistry that when we are talking about ketone doesn't really give positive test to reducing reaction, reduction to oxidation reaction. The ketone do not really give positive test. Although ketone can further be reduced. They can further be reduced, but they can never be further oxidized. They can be reduced to alcohol. That's to secondary alcohol. Whenever we reduce ketone, we are going to have secondary alcohol. That's what we know. But whenever we are oxidizing, there's just like oxidation of ketone. That's what I want you guys to understand. So whenever you are talking about reducing property, you are going to be talking about aldehyde and also alcohol, terminal alcohol. But one thing I want you guys to get is that there is terminal alcohol in the structure of monosaccharide that contain what? Aldehyde functional group. And at the same time, there is terminal alcohol in the structure of what? Monosaccharide that contain ketone functional group as well. So I'm going to explain everything one by one now. Now let's move to the reduction properties in general. Let's move to the reduction aspect. So that's where I'm going to be explaining some things that you need to understand. Now, listen. So we have different reducing agents. We have different some types of reducing agents. Part of it is when you are talking about the sodium amalgam. Sodium amalgam is a type of reducing agent. So get down. So, but one thing I want you guys to understand is that the aldehyde or ketone group of monosaccharide, and it can reduce what to different alcohol. You know, whenever you're talking about reduction, right? Reduction is simply, it can be what? Reduction is basically we're talking about addition of what? Addition of hydrogen or removal of what? Of oxygen. But in this kind of scale, in this kind of scenario, we are not talking about the removal of what? Of oxygen. We are basically talking about what? Addition of what? Of hydrogen, right? And that in that case, we'll be talking about different types of reducing, or let me just say different types of corresponding reducing agents or reducing intermediate that is formed whenever aldose sugar, whenever it's undergo reduction, right? Now in that case, let's talk about the first one, which is glucose. Whenever glucose is reduced, it's reduced what? To sorbitol. That is what I'm basically talking about to is that whenever there is reduction of what? Of glucose, which is an aldehyde, whenever it's reduced what? To sorbitol, right? The next one is that whenever this case, which is galactose, whenever galactose reduced to what? To dositol. That's the alcohol that is formed, the corresponding alcohol that is formed whenever what? Galactose reduce. And don't forget, aldehyde, whenever they reduce, whenever aldehyde undergo reduction, they are going to form what? They are going to form primary alcohol. And these are the alcohol, the corresponding alcohol that are produced whenever this monosaccharide undergo what? Reduction reaction. The next one that we can have is case of what? Of mannose. Whenever mannose undergo reduction reaction, sorry, whenever it's undergo reduction reaction, it's going to form what? Mannitol, right? It's form mannitol. Yes, of course, fructose can also undergo what? It can also undergo reduction reaction, and whenever it's undergo reduction reaction, because we have two hydroxy group, one is found on carbon number 1 and the other one is found on what? On carbon number 6 at the same time of fructose. Yes, when it's found on carbon number 1, the same structure of carbon and the orientation of atom on fructose on carbon number 1 and also what? Carbon number 6 is almost the same thing. So we can have two products here. We can have it to what? To be mannitol. We can have it to be mannitol, or we have it to what? To be sorbitol. That's what we can have. We can have it to be mannitol or sorbitol. And don't forget, fructose and glucose and also this mannose at the same time, whenever they are kept in an alkaline medium, they undergo what? Transformation, right? And in that case, that means you are talking about tautomerization. So that shows that glucose to mannose and fructose, they always produce what? A common intermediate, which is referred to as what? Aldehyde. And this aldehyde make it very, very possible for glucose to reduce to sorbitol and glucose to reduce to what? To mannitol or what? Fructose to reduce to what? Mannitol or what? Or sorbitol. Right? And if we look at it down, this fructose can reduce to either to give us what? Either mannitol, which is mannose, reduction, the reduction product of mannose, or it's produced sorbitol, which is what? Reduction product of what? Of glucose. And in that case, it's because whenever glucose what? Is kept in an alkaline medium, whenever glucose is kept in what? In an alkaline medium for several hours, it can undergo transformation to form what? Fructose or what? Or mannose. And that's actually what happened. What that's it that whenever fructose undergo what? Reduction, it's going to give us what? Mannitol or what? Or sorbitol as its corresponding alcohol. Now the next one that we can have is the case of what? Of ribose. Right? Whenever ribose undergo what? Undergo reduction, it give us what? Ribitol. And that's what you have in what? In the case of what? Of ribose. Right? So another thing that I want you guys to understand that I just need to chip in is that accumulation of what? Of dositol and also what? Mannitol in the body is very, very, very dangerous. And sorbitol rather. Accumulation of dositol and sorbitol and dositol in the body is very, 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 very dangerous. Right? Because it can lead to what is referred to as osmotic effect. It can cause osmotic effect. Right? And whenever there is osmotic effect, that is the body, like, there will be swelling in the cell. The cell will actually swell, and whenever cells swell, it can what? It can burst, right? So that's just basically what happens whenever there is accumulation of the sorbitol and also dositol. But I'm going to explain them in detail in a separate video in details. So that's just it. So this is basically the reducing properties of what? Of monosaccharide. So the question is now that can polysaccharides or oligosaccharide, can they undergo reduction, or let me simply say, do they have reducing property? The answer is yes. And it's just so that maybe you are basically going to subject your polysaccharide and also oligosaccharide into reduction reaction like that, and they are going to, no, that's not it. You first hydrolyze them. That is, you first break the bond. You hydrolyze them into what? To monosaccharides. You first hydrolyze them into monosaccharide. That is, you split them into what? Into their simplest form, which is monosaccharide. Then you can now subject the monosaccharide that is formed from poly and also oligo to reducing reaction. And in that scenario, you can actually determine what the reducing properties of what? Of the polysaccharide and also what? Oligosaccharide. So that's just it. So let's move to another aspect, which I'm going to be explaining in a separate video. That is dehydration and also what? Oxazole formation. It's also part of the parts of monosaccharide. So if you enjoyed this video, don't forget to like, share, and subscribe. Thanks for watching.